Morning, everybody. Mr. Spottelson here. Today is Monday. This is the first assignment of the week. Just a couple announcements here first. First is just a heads up. We've got 2 weeks left. So this week and next week, believe it or not, crazy thing is we're only going to do 2 more lessons all year long. So you think about the million lessons that we've done. We've got 2 more. Okay. Um, with that being said, we are going to basically we're going to do 12 section 12.3, section 12.4. That's what we decided was the most important. And then next week we'll do a review, and then we'll end on a Wednesday quiz, and then that'll be it. You turn that quiz in, and you're officially finished with Mr. Spottelson's class. So that is that. So I'm going to encourage you guys to make sure you stay up to date these next 2 weeks in all your classes. Okay, that's going to be a summative grade that goes in right at the end. Okay, and that's really going to affect your grade. If you take a 0 out of 40 on the simplifying rational expressions quiz, it's going to be hard to recover. Okay, so today we'll go through this. I have a shorter assignment for you guys to complete, and then we'll be on our way. Okay, so section 12.3, simplifying rational expressions. A rational expression is an algebraic expression whose numerator and denominator are polynomials. Okay, so when you think of a rational number, all right, we usually think of a fraction. Okay, and in this case, a rational expression will have polynomials in it. So x minus 4 or x squared minus 3x plus 8, all those different polynomials and stuff will be in a rational expression. Okay. Another key point of this is the value of the polynomial expression in the denominator cannot be 0. Okay. And what that means is if you have a fraction, you can have, I can have something like 0 over 3 because that equals 0. Okay. I can't have 3 over 0 because that's undefined. Okay, you can plug that into your calculator. You can't divide something into 0. Okay. So this means that rational expressions may have excluded values. And what does it mean by that? Well, here's a rational expression, okay? X minus 2 over x plus 3. We have to think here, what value would make the bottom equal to 0, which would then make it undefined here? Well, you can set it equal to 0, but you should be able to see here, if I take negative 3 plus 0, I'm going to have x minus 2 over 0, and that's no good. So x cannot equal, so we put an equal sign and then a slash, negative 3. Okay. We could have a situation like this. All right. Let's say we have one that's x plus 2 over, and then I do x squared plus 4x plus 4. No, I don't want to do plus 4. Let's do plus 9x plus 20. Okay, so I factor that out. I have x plus 2 over. What multiplies to get me 20 that adds to get me 9? It would be x plus 5 and x plus 4. Now, what can't x be? Well, either of these can't be 0. Neither of them can be. So if this one's 0, 0 times that would just be 0, and the denominator would be 0. So x can't be negative 5. And then here, this one can't be 0, so I have negative 4 plus 4 would equal 0, and 0 times whatever this is would still be 0, so x can't be negative 4. So right there, I have two values that x cannot be. Those are called excluded values, okay? Let's look at a couple examples of that. Find any excluded values of each rational expression. I hope that you can just look at that and say, well, x can't be negative 4. Okay? And then circle that and be done. If you can't look at I'm sorry, I put x. It could be g. Sure, it should be g. Now, if you can't look at that and you can't tell that it's negative 4, you can always do g plus 4 when it equals 0 and then solve for 0 or solve for g, and you're going to get g cannot equal negative 4 because 0 minus 4 is still negative 4. Okay, so there's the first one. All right. Okay, same thing here. I'm hoping you can just look at that and say t cannot be 5. All right. Here we actually have to factor this. So what multiplies to get me 4 that'll add to get me 5? Okay. What multiplies to get me 4 and adds to get me 5? My numerator, y minus 2, is going to stay the same. So I need multiply to get me 4, and I need add to get me 5. In this case, it's going to be 4 times 1 equals 4, and 4 plus 1 equals 5. So I'm going to have x plus 4, x plus 1. And then I have to think what values are going to make either of these 0. Well, x cannot equal, in this case, x cannot be negative 4. And over here, x cannot be negative 1. All right. I think I got one more example here. Yep. Okay. 3k squared over x squared minus 7x plus 12. Again, we're just finding the excluded values. So from here, we're going to have 3k squared on the top. What multiplies to get me 12 that adds to get me negative 7? In this case here, it's going to be x minus 4 and x minus 3. So what can x not be? In this case, x cannot be 4 and x cannot be 3. Those are what make inside these little binomials 0. Okay? All right. I'm going to pause the video for a second, go let Thumper out. He's kind of roaring right now, so I'll be right back. All right. Sorry about that. I'm back. Okay, so moving on now. A rational expression in its simplest form, the numerator and denominator have no common factors except 1. Remember that to simplify fractions, you can divide out common factors that appear in both the numerator and the denominator. You can do the same to simplify rational expressions. Okay, I think that's a very complicated explanation to say what we have to do here. Okay, all right. So x plus 2 over x squared plus 5x plus 6, we need to simplify this. Okay, the top can't simplify at all. That's going to stay as x plus 2 for now. Here, we need to factor this. What multiplies to get me 6 that adds to get me 5? In this case, it's going to be x plus 2 and x plus 3. The reason for that, 2 and 3 multiply to get me 6, and at 2 plus 3 adds to get me 5. Now, here's what we can do. I have an x plus 2 on the top and an x plus 2 on the bottom. If I take x plus 2 divided by x plus 2, I get 1. These cancel each other out. They don't change the expression at all. Okay? Now, there's nothing left up top but a 1. When we cancel everything out, we leave just a 1 in the numerator, and then the only thing left over here is x plus 3. So I have 1 over x plus 3. Okay? Again, when we have the same thing, that's that GCF. Those cancel. I'm left with just 1 over x plus 3. This one's very familiar over here. They're about the same. Okay? So again, my m plus 2 can't change yet. Now I factor. What multiplies to get me negative 10 that adds to get me negative 3? So we have negative 10. I know it's going to be negative 5 and 2. Oh, and then if I add those, I'm going to have negative 3. So I multiplied to give me negative 10, and I added to give me negative 3. So I'm going to have x minus 5 and x plus 2. Cancel out I put x's, but I meant m's, okay? I cancel out my m plus 2's, and I'm going to be left with 1 again because there's nothing left in the numerator over x minus 5. Okay? I hope that's not too complicated yet. Okay? Moving on. All right. Now, this time we can factor both of these. I can factor the top and I can factor the bottom. W squared minus 4. Okay, break out the cobwebs for a little bit. That's a difference of squares. W2 is a perfect square. 4 is a perfect square. So when I factor that, it's x plus 2 and x minus 2. If it's a difference of squares, we take 2 and 2, the square root of 4, and then we do 1 positive, 1 negative. And I'm sorry I keep doing x. I don't know. I'm just so trained to deal with x, I guess. But this is w. But we do 1 positive, 1 negative in the square root of 4, which is 2. Okay. On the bottom, we do what multiplies to get me 12. That'll add to get me negative 8. In this case here, it's going to be, let's see. I got to add to get me negative 8. I think we're going to go with negative 6 and negative 2 because negative 6 times negative 2 is 12, and negative 6 plus negative 2 is going to equal negative 8. Good. So I'm going to have w minus 6 and w minus 2. Again, these w minus 2's will cancel, and I'm left with my correct answer, which is w plus 2 over w minus 6. All right. Moving on. Okay, this is where things get a little bit more complicated. We want to simplify everything first. That's what I always tell everybody. Simplify everything first. 5t to the third, nothing I can simplify. So that's going to stay as 5t to the third. Now, on the bottom here, there's a GCF that can be factored out. Okay. The common factor between 15 and 10 is going to be 5. And let's also not forget that there's 1t that match up. So in this case, I'll be left with 2t plus 3. Okay? Now, in this case here, I have a 5t to the third and a 5t. Okay? We're going to use, again, some things that we've learned in the past. Number 1, my 5 and my 5 cancel because it's 5 divided by 5. That's 1. Then if I have a t to the third and a t here, and I'm dividing, what do I do with the exponents? Well, we subtract when they're in fractions. So I have 5, so I would have t. So the top is going to be t 3 minus, and then the exponent here is 1. over this bottom that I can't do anything with, which is 2t plus 3. So I simplify this 2, 3 minus 1, so I'm going to have t squared over 2t plus 3. There's nothing else that I can do with that there. Okay, that one's a little bit more complicated. There's a lot of different things that we've worked on throughout the year that goes into that problem, including factoring out the GCF here, which was 5t, and then understanding that because they're fractions here, t to the third over t, I'm going to take t 3 minus 1 to get t squared. Okay, and remember, it always goes on top as well. That's another explanation there that I need to, if I'm doing the problem, the part that I'm actually calculating goes up top. Okay, let's look at one more. We're going to skip E. It's hard for no reason. Okay, for F, all right, so any situation where you see that it's the R's and the are behind the 18 here, you see how the variables in the back. Let's move it up front by rearranging this. So remember, the sign goes with it, so I'm going to have negative 6r and then plus 18. Here, I have a GCF that I can factor out, which is 2. Can factor out of all of those. So here I have 2, and then I have r squared plus 4r minus 21. Okay, let's go ahead and factor out here. So if I can also factor a GCF of negative 6 out here, so I have negative 6 and then r minus 3 over, and now I have 2, and then I can factor this. So what multiplies to get me negative 21 that adds to get me 4? Okay, so in this case here, it's going to be 7 and negative 3. 7 times negative 3 is negative 21, and 7 plus negative 3 is 4. So I'm going to have x plus 7 and x minus 3. Okay, right off the bat, you should see that my r minus, I put x again, but you get the picture. Right away, you can see that my r minus 3's cancel. Now, I can also simplify this. Negative 6 over 2. If I take negative 6 divided by 2, I get negative 3. And again, since I do an operation, it's the same thing here. If I do t to the third divided by t and get t squared, it goes on top. If I do negative 6 divided by 2, it goes on top. So my negative 3 goes on top here. Those canceled, so I'm left with, on the bottom, just an x plus 7. Okay? All right. Here's our assignment for today. Page 870, numbers 2 through 6 even, and 11 through 18 all. Okay? A little bit more of a complicated section. I didn't realize all the little factors that I would explain and go into this when I made it. Okay, if you have questions, please ask. Don't just be like, oh, it's the last section. I know there's a lot of you that want to finish this 9 weeks off strong. Okay, we don't have a final exam or anything like I had said at the beginning of the year we'd have. There's none of that because we're online now. So I know there's a lot of you that want to finish strong. Don't just say, oh, it's the end, I'm done. Okay, it's a high school credit. Let's get a good grade on it to finish the year. If you have questions, find a way, contact me. I'm more than willing to meet. Okay? Again, this is due Tuesday at 11:59. All right. Thank you, guys. See you next time. We only got 3 more next times. See you.